Hello everyone, I am now Dilshan. Today we are going to find out about BRAS. Broadband Remote Access Server. Okay, let's move to the presentation. First, we need to know what is this BRAS. A broadband remote access server is an access gateway that functions as a bridge between an broadband access network and a backbone network providing basic access and management functions. Broadband Remote Access Server is specialized server based at an ISP network that facilitates the convergence of multiple internet traffic sources. These sources include cable, DSL, Ethernet or broadband wireless. BRAS is a network device used to route traffic to and from broadband remote access devices such as digital subscriber line access multiplexers on an internet service provider's network. The BRAS sits at the edge of an ISP's core network and aggregates user sessions from the access network. Okay. Next, we want to know about why we use BRAS. The key benefits of using it are: they provide a single point for change control. BRAS is Common Access Agnostic Operational Model. It is multi-service node MSAN independent. If network changes are required, it's better to make changes at a single BRAS server than at dozens of devices. Okay, then we need to know about what is its functions. Aggregates the circuits from one or more link access devices such as DSLAMs. Provides layer 2 connectivity through either transparent bridging or PPP sessions over Ethernet or ATM sessions. Enforces QoS policies. Provides layer 3 connectivity and routes IP traffic through an internet service provider's backbone network to the internet. A DSLAM collects data traffic from multiple subscribers into a centralized point. It can be transported to a switch or router over a frame relay, ATM, or Ethernet connection. The router provides the logical network termination. Common link access methods include PPP over Ethernet, PPP over ATM, encapsulated sessions, bridged Ethernet over ATM or frame relay RFC 1483, RFC 1490 or just plain Ethernet. In the case of ATM or frame relay based access, individual subscribers are identified by virtual circuit IDs. Subscribers connected over Ethernet based remote access devices are usually identified by VLAN IDs or MPLS tags. By acting the network termination point, the BRAS is responsible for assigning network parameters such as IP addresses to the clients. The BRAS is also first IP hop from the client to the internet. The BRAS is also the interface to authentication, authorization, and accounting systems. Okay, we will look for the next one, BRAS functionality evolution. BRAS device heritage can be traced back to dial-up remote access servers that terminated user PPP sessions established over the analog phone lines, authenticated remote caller credentials, and provided connectivity to the internet. As the internet market continued to explode and with rapid growth of bandwidth-intensive network applications, dial-up access limited to 56 kilobytes per second speeds has become insufficient and given way to broadband network access technologies, primarily DSL. As PPP remained the protocol of choice for tunneling of subscriber connections over ATM and DSL lines, broadband remote access servers have replaced RASs as PPP termination devices that authenticated user credentials and routed the subscriber traffic onto the service provider networks and the internet. As DSL broadband service delivery continued to evolve from high-speed internet access to a wide variety of triple pay offerings, the fundamental functionality of BRAS has also changed. Okay, now we are look for first generation. software-based BRASs. As the DSL service was initially introduced in late 1990s, competition was limited and service was first offered to early adopters. Industry acceptance was slow and BRAS vendors often tailored their products to each service provider's environment and requirements. The first generation BRASs were software based and used general purpose hardware platforms to allow for rapid customization and prototyping, which led to low performance specifications. Functionally, first generation BRASs provided triple P session termination and subscriber management functions such as AAA and IP address assignment. Second generation centralized architecture hardware based BRASs. During 2002-2003, DSL service was becoming a mainstream broadband access technology with standardized delivery architectures. With soaring competition and bandwidth serving as the only differentiator, DSL service began to commoditize. Consequently, providers started looking into value-added services as potential new sources of revenues. Triple Play was born. Accommodating for these trends, second-generation BRASs were implemented in hardware and had much higher performance specs. At the same time, functional scalability was limited as BRAS devices were still designed around centralized processor-based architectures and were optimized for single-service internet access. Attempts to add advanced features such as filtering or QoS still led to performance degradation. Advanced series were widely deployed that included ProDSL, VPNs, VoIP, IPTV, VOD, and interactive gaming. Triple Play has become mainstream part of the broadband service portfolio. In order to comply with the new requirements, third generation of BRAS devices has undergone a significant shift in functionality to support the complete range of high bandwidth multimedia intensive triple play services. In third generation of BRAS's centralized hardware model gave way to modular, highly scalable distributed architecture that allowed service providers to deliver the session capacity and throughput required to support advanced broadband service delivery. In this stage, the BRAS functionality has also begun to be integrated into service edge routers that provided the following capabilities in one unified platform: ATM and Ethernet aggregation, session termination ATM PVC triple P, AAA authentication authorization accounting using PAP, CHAP, radius, DHCP, option 82. Comprehensive IP routing, BGP, OSPF, RIP IP address management, DHCP server, relay proxy services. Integrated Layer 2 switching, ATM, Ethernet, MPLS. Policy management and dynamic per session QoS. IP multicasting routing, PIM, MBGP, IGMP. In addition to these capabilities, high-end third-generation BRASs on-service edge routers typically integrate firewall-grade security enforcement, intrusion detection and prevention mechanisms, and content filtering, as well as fault tolerance provisions such as switch fabric redundancy and hot swappable modules to ensure high availability and near zero downtime. PAP CHAP authentication protocols defined in RFC 1334 and used by point-to-point protocol PPP. Radius remote authentication dial-in user service authentication, authorization and accounting protocol defined in RFC 2865. DHCP option 82 relay agent information option and extension to DHCP protocol defined in RFC 3046. DHCP option 82 in DSL environments can be used for subscriber line authentication. We are going to find out next BRAS architecture and deployment classification. From the architecture model standpoint, BRASs fall into three distinct categories: Software-based BRAS architecture using general-purpose hardware platforms was typical for early first-generation BRASs. Centralized hardware-based BRAS architecture with majority of intelligence placed in the central processing unit. Centralized BRASs were designed and optimized for high-speed internet services, had high performance characteristics but did not scale well. Distributed or modular hardware-based BRAS architecture with functional intelligence distributed between ASIC-driven line cards of variety of technologies, Gigabit Ethernet, OC12, OC48, and routing or switching modules, edge service processors. Distributed BRAS architecture provides for exceptional flexibility, scalability, and power and allows service providers to deploy the number of types of interfaces as well as functionality portfolio that fit their requirements and budget while retaining the ability to add capacity and capabilities as the needs grow. The majority of modern BRASs or service edge routers have a modular distributed architecture. By deployment scenario, BRASs can be roughly divided into the following classes. BRAS architecture and deployment classification. From the architecture model standpoint, BRASs fall into three distinct categories. In search of this centralized hardware-based BRAS architecture with majority of intelligence placed in the central processing unit. Centralized BRASs were designed and optimized for high-speed internet services, had high performance characteristics but did not scale well. Software-based BRAS architecture using general-purpose hardware platforms was typical for early first-generation BRASs. Thank you for watching my video. Stay home, stay safe.